So let's think about how you can be first in the world to discover something interesting. Now this is really hard. Some of the reasons we've already talked about, but just look at the competition. This is the number of PhDs granted annually around the world. Now, not all of these are scientists, not all of these will go on to be researchers, but it's very scary. Back when Einstein was doing his groundbreaking work, look at how many PhDs there were in the world and compare it to the number now. There's a lot more competition. As we saw before, the number of PhDs in most developed countries plateaued for a while. What's happening mostly is it's rising due to countries like China and India, which are graduating far more PhDs than they were even 10 years ago. But even in Australia, there's been exponential growth in the number of PhDs graduated. Though mostly this is not in physics. So what this means is that it's very hard to succeed as a researcher purely by just being smart. I'm not saying you're not smart, but there's 160,000 other smart people getting PhDs around the world every year. Add them up over 10, 20, 30 years, then you're talking about millions of competitors, literally millions of other people working in the same field, all of whom are smart enough to get PhDs. So there's a lot of incredibly smart, ambitious people struggling to get jobs, and you're competing with all of them. So what most people think is you're not going to win this competition just by being smart. Maybe you can. Maybe there are a few really smart people who just do it by being really, really smart and thinking up things faster than anybody else. But normally you need an edge. You need some sort of competitive advantage that allows you to discover things when other people can't. Now, what could these edges be? Very often it's access to some piece of equipment. For example, if you build a new spacecraft like the James Webb Space Telescope, in return for building it, you get exclusive right to use it for the first 6 months or year or something like that. And that's a reward for those who might have spent 20 years building the instrument, that they get first dibs at doing the science with it. It could be that someone's just produced a new particle accelerator or gravity wave detector or a new heavy ion accelerator or some new piece of kit. And then if you have access to it, and all those other hundreds and thousands of physicists around the world do not have access to anything comparable, then that will allow you to do groundbreaking work. And you can be reasonably confident that you'll be first. Of course, everybody knows this, so it's very competitive to get access to these things. Very often it involves persuading the government to cough up large amounts of money to provide it, so your key skill might be doing that, or more commonly finding someone else who's persuaded the government to cough up money for example, a new telescope or a new accelerator, and then joining their research team. But it could be other things. It could be supercomputers. For example, if you're a top AI researcher now, you need access to a large data center full of GPUs. And so you have to join one of the companies that can provide this, otherwise you've got no hope of doing the research. But if you've got access to one of these things, you can do research and no one can scoop you on it. But it could also be a software package, or even some skill. There's a lot of implicit skills that people have. For example, the people here at Mount Stromlo Observatory know how to build good astronomical instruments. A lot of that's information you can't really write down. So it'd be very hard for someone at a random institute that has no experience in this to develop it. Or it could be in biology, there are particular stem cell lines or reagents or some special thing that you have that other people don't. Or it could be that you have a special skill that your rivals don't. This often is people who've crossed disciplinary boundaries. They might have worked in two different fields and they can apply the skills from another field to the first field that gives them an edge that most people in the new field don't have. And there are other possible edges. You have to think strategically about this. What is my edge? What can I do that other people can't easily reproduce? Let me give you some examples, some friends of mine who've had long conversations about what their edge is. So, of course, we'll start with Brian Schmidt, who got the Nobel Prize for leading one of the two teams that discovered dark energy. And how was him, as a young research fellow on a fixed-term contract, able to do something like this? And I won't say first, because two teams came up with the answer at the same time, but at least joint first in discovering something that's very interesting, accelerating expansion of the universe. So This is a combination of things. Partially, he was relying on a bunch of breakthroughs made by other people. For example, Mario Homoy and his group in Chile, who were friends with Brian, discovered that you could use a particular type of exploding star, type 1a supernovae, to very accurately measure distances to galaxies. Once that discovery was made, lots of people around the world at once realized that allowed discovery of things like dark energy. But that discovery by itself was not possible without two technological discoveries: the development of large format digital detectors, giant CCDs as they're called, which allowed you to get digital images with very high sensitivity of very large areas of the sky to find the supernovae that you could use for this. And then once you found the supernova, you needed a really large telescope with a powerful spectrograph to measure its redshift, and hence the expansion of the universe. These are the new 8-meter class telescopes that were just coming online at that point. So one reason why no one else could beat Brian to this was because his discovery relied on 3 breakthroughs, all of which came to fruition in the early 1990s. And without them, no matter how smart you were, you couldn't have done this in the 1980s or 1970s or any previous time. So one important skill was to know, keep your finger on the pulse of what's going on, to realize that there are all these breakthroughs that other people have done and say, oh, if we put this breakthrough together with that breakthrough, together with this breakthrough, that allows us to do something we couldn't have done before. But then, once these 3 things cropped up, lots of people around the world were keeping an eye on all these things and realized more or less simultaneously that suddenly this new project was possible. So why was Brian able to get there joint first? So one advantage he had is his very good social skills and his network, because you needed so much telescope time and such a large team. You had to put together a team of 20 or 30 people with access to dozens of telescopes around the world. And for that you needed his social skills, and Brian knew that he was good at networking and good at putting teams together. A lot of scientists are not. And that was a competitive edge for him. But he had 2 more competitive edges. One was he knew that there was a weakness in how other people worked, that most senior researchers, because the rival groups were generally founded by senior researchers, came from an era before software was really important, and they tended to always underestimate the importance of software. They would think about, okay, we'll need this big telescope, and yeah, we'll write some software to process the data and find the supernovae, but they kind of underplayed the significance of that. Whereas as a younger generation scientist, Brian realized that the importance of software was really important, and that they were going to need to put a lot of resources into actually writing the software to take this huge amount of data and find the supernova and measure the distances. And a lot of the rival groups failed because they underinvested in that. They assumed that people would just write the software in their spare time. And thirdly, Brian had just been appointed to a research fixed-term contract here at ANU, and that meant he was basically 100% researcher, which meant that he could put the time in to write the software to make this whole thing work. Whereas most of his rivals were more senior people, which means they had jobs that involved large amounts of teaching or administration or technical support, and so they didn't have anything like as much time. So what allowed him to do his Nobel Prize winning work. Of course, he wouldn't have won the Nobel Prize if he discovered what he thought he was going to discover, so that's kind of a bonus by finding something unexpected. But it would have been very interesting anyway, and it wasn't possible in the past. It relied on some technological breakthroughs, but those technological breakthroughs were available to many different researchers. And then there were specific skills, his particular skill, and his identification of weaknesses in the other teams that allowed him to do well. So thinking strategically. Here's another example. Matthew Collis, previous director of Mount Stromlo Observatory and researcher up there at the moment. He carried out the 2DF Galaxy Redshift Survey. This is a survey that measured acoustic peaks and was able to nail down the cosmology of the universe. Hugely influential, huge number of citations and papers, made his name as a researcher. How was he able to do this? Well, there was a technical edge. Australia does not have the biggest and most powerful space or ground-based telescopes. It does have some good telescopes from a previous generation, like the Anglo-Australian telescope. These telescopes are not particularly cutting edge in terms of their size or power or location, but because they're not cutting edge, you can get a lot of time on them. So Matthew was looking for a project that would use this edge, something that would require a lot of telescope time, like hundreds and hundreds of nights of telescope time. He wasn't going to be able to compete with things that required like a few hours of telescope time in the biggest telescope because he didn't have access to that. But he did have the edge of getting hundreds of hours on a medium-sized telescope. By itself that was not enough because there are other medium-sized telescopes around, but a research group at the Anglo-Australian Observatory had developed a new technology, fibre optic positioning systems. What this is a robot that positions fibre optics in the focal plane of the telescope, each of which can capture the light from a different galaxy, so you can get 400 spectra of 400 different galaxies at the same time, whereas every other telescope in the world could get maybe 2 or 3 at the same time, but no more. So he'd noticed we have a medium-sized telescope, not in the best of sights, but we get a lot of time on it. And we have this new device that can take lots of spectra at once rather than just one at a time. The third advantage, which he was very explicit about, I remember him telling me about this at the time, was that he felt that for this, being in Australia was an advantage. Australia is a long way from the world scientific centres and the US and Europe. But people at the world scientific centres tend to always be chasing the latest big thing. There's very competitive, very short-term thinking. And he reckoned that being a bit further away meant that you could build a longer-term project. You weren't under such intense competitive pressure. And so his idea was that maybe we could do a project that would last 5 years and take advantage of the new technology and the telescope time. And that might mean for the first 3 or 4 of those years you're not going to produce anything. In many parts of the world that would be career death, but he had a longer-term contract that he felt he could survive several years without getting results out in return for getting a really big result at the end, and he felt that most other researchers around the world couldn't do this. So that was an advantage of his particular career situation and being in Australia. So that was the strategic thinking. Once again, it's a combination of seeing new technologies, new research directions, but also trying to work out what situation are you in and does that give you an advantage, and are there weaknesses and flaws in other people's situation that mean they can't take advantage of this?